Hello, and welcome to today's lesson on linear inequalities and graphs. And this is actually the second part on two videos that cover those topics that in Standard 2.3a and 2.3b, and then in that Study Island topic, linear inequalities and graphs. So if you're working on any of those things, this is where you want to be. And in this video, we're going to be talking about inequalities with two variables, inequalities being less than, greater than, less than, equal to, greater than or equal to, and then word problems that involve inequalities also. So before we get started, just remember our study tips that where you can pause anytime you need to. So if you're taking notes and I'm going too fast, just pause and catch back up and then join us again. And also if you are taking, and if you're writing down an example, go ahead and pause, try the example out, and then press play and see how well you did, and that way you can get a gauge for how much more practice you need to do. So I'm excited that you're here, and let's go ahead and take a few notes.
So you want to remember that anywhere that is shaded on a graph is considered an answer. So when we're graphing, and I'll show you some examples, but we're using two variables today. So anytime we shade above or below that line, anything that gets shaded over any of those coordinates is an answer. So keep that in mind. And so when we're graphing with two variables, there's two things you need to remember. First of all, when we have this line, this equal to line underneath, so whether it's less than and equal to or greater than and equal to, it's going to be a solid line when we graph on the x and y coordinate plane. However, if that equal to part isn't there, if it's just a plain less than or just a plain greater than, we're going to draw in a dotted line or a dashed line like this. Because a solid line means that we can have answers on the line for that problem, and dashed means we can't. So if you have a solid line underneath, you're going to draw a solid line on your graph. It's a little way to remember that. The other thing you need to remember is if you have a less than symbol, whether it's less than or equal to, or the plain less than that means smaller, you're going to shade underneath the line. So here's two different lines. One's going downhill, one's going uphill. So underneath those lines you would shade down here. Or underneath this line, you would shade down here. It's kind of like, where would you stand to get out of the rain, is one way I've heard it described. And it would be the opposite for the greater than symbol. So whether it's a greater than or equal to, or a less than or equal to, you would shade above. So there's two lines, and if I'm shading above, it's going to be on top of the line. So that's going to look like this. So remember, if it's less than of any sort, it's shade below. If it's greater than of any sort, you shade above. Here's our first example. So remember, anywhere that is shaded can be an answer to this word problem. So here, that means this coordinate 4, 1 could be an answer. Or because it's a solid line, the coordinate 3, 6 could be an answer. Because it's a solid line, you can have answers on the line. So here, this coordinate 7, 8 could be an answer. So that's how we're looking at these graphs, and that's what I mean by anywhere that's shaded is an answer. So let's go ahead and read the problem now. Trey is planning to serve hamburgers and hot dogs at his cookout on Sunday. Hamburger meat costs $2 per pound, and hot dogs cost $3 per pound. He wants to spend no more than $24. Which graph below shows the possible combinations of pounds of hamburger meat and hot dogs Trey can buy? All right, so if he doesn't want to go over $24. So if we look at our four graphs, the way I'm going to do this is I'm going to look at my hamburgers and my hot dogs. And if I get all hamburger meat, what's that going to look like? Okay, so if I get all hamburger meat, hamburgers are my X's, because it's what the X in all my answers, it's what the X axis is labeled. And hot dogs is going to be my Y, because that's what the Y axis is labeled in all my examples. So if I get all hamburgers, that means my Y coordinate is 0, because I'm not getting any hot dogs. So what's that going to look like? Well, if I have $24 to spend, and hamburgers are $2 a pound, and I have $24 to spend, if I spend that all on hamburgers, how many pounds can I buy? Well, 24 divided by 2 is 12. So I can get 12 hamburgers if I get only hamburgers. So that means I'm going to need to have that point on my graph. So let's do the same for hot dogs. Okay, so this time around, if I get only hot dogs, I'm getting 0 hamburgers. So that means my X coordinate for hamburgers is going to be 0. So same thing, only this time the cost of hot dogs is $3 a pound. And I still have that $24 at the most I can spend. So if I spend all of it, I can get 8 pounds of hot dogs. So that means my coordinate here is going to be 0, 8. So that means I just found my X and Y intercepts. So I'm going to go ahead and find the lines that have these coordinates. So if I go over here, I can have 8 hot dogs, 12 hamburgers. Okay, so this one's good. So this one has the right line. So we're going to, once we find the ones with the right line, we'll go back and talk about whether we want to shade above or below. Okay, this one has 8 hot dogs. This one has 12 hamburgers. So this one has the right line. This one has 12 hot dogs. I need 8, so it's not going to be X. Okay, this one has 12 hot dogs. I need 8 again, so these ones were backwards, so it's not going to be Z either. So here, the only difference between W and X is that W is shaded below and X is shaded above. Well, if he wants no more than $24, that means he wants to spend $24 or less. So it has to be less than or equal to $24. So what he spends has to be less than or equal to $24. So since it's less than, you're going to want to shade below the line. So your answer is W. And you could even take a point and see if it makes sense. So if he gets 2 pounds of hamburger and 3 pounds of hot dogs, so 2 hamburger is $2. So 2 times 2 is 4. And 3 hot dog, 3 times the 3 pounds, $3 per pound is $9. So 4 plus that 9 is 13. Well, that's under the 24 he has to spend, so that one makes sense. Let's read this next example. Amy is very allergic to pollen. She found this graph in a magazine showing the maximum scores per cubic meter of pollen in the air of certain types of flowers, the purple pansy. If the meteorologist gave the local count, which of the following would be representative of the purple pansy? All right, so we have this graph, spring pollen count. We have flowers on our X, pollen count on our Y. And our answers are giving us different combinations of flowers and pollen count. So what we need to do is see which one of these actually is an answer. So which one of these is in the shaded area, and because it's a solid line or on the line. So we're just going to look at these points. So we have 400, so 5 flowers, 400 pollen count. That's not in the shaded area. So that's not an answer. So not A. Okay, we have 2 and 200. That's just barely out of the shaded area, but still not in the shaded area, so it's not B. Okay, we have 7 and 250. So 7 and 250, that is in the shaded area. So that's most likely going to be our answer, letter C. But let's go ahead and look at letter D just to make sure. So we have 10 and 350. Once again, just barely out of the shaded area, but out of the shaded area, so it's not D. So our answer is C. Okay, this example is similar. It says the giraffes at the zoo eat leaves, branches, and other foliage all day long. The zoo attendant in charge of the giraffes created the inequality below to track eating habits. Use the graph to determine which of the following occurred. So we have giraffes on the X, pounds of foliage on the Y, and we have these different combinations, and they want to see which one is actually an answer, which one actually occurred. The difference in this problem is now I have a dashed line. Because I have the dashed line, any answers on the line aren't solutions. So if any of these fall on the dashed line, they're not going to be actual solutions. They have to be in the shaded area because it's dashed. So let's go ahead and look. So we have 1 giraffe and 50 pounds. 1 and 50 is outside, so A is not an answer. B, we have 5 giraffes and 130 pounds, so 5 and 130, that one looks like it's going to be outside, but we'll go ahead and check the rest too. That one's a little iffy because it's not on a line. So we have 2 giraffes and 45 pounds. So we have 2 and 45 is definitely in the shaded area. So C is most likely going to be our answer, but let's go ahead and check D just to be safe. So we have 4 giraffes and 150 pounds. Oh, that's definitely outside. So C is definitely our answer. In this example, they want us to match the graph to the equation. So which inequality is graphed on the coordinate plane? If you look, they all have the same slope. They all have the same y-intercept. The only difference is they have all 4 have a different inequality. So they want to know which inequality would you use for this picture. So first of all, it's a dashed line. Remember, back to our nose, if it's a dashed line, that's going to be the plane less than or the plane greater than. So I can instantly get rid of B and D because they have the equal to part. And then I have to think about, okay, is this shaded above or below the line? Okay, this is shaded above. So because it's above, that's going to be the greater than symbol. So the one with the greater than symbol is letter A. In this example, we're going to start to look at word problems with inequalities. Now, these are going to work exactly the same as our word problems that have equal signs, where the slope, the number that goes in front of x, is the per number, so the number that changes because slope is rate of change, and we use an M to stand for slope. And then we have our y-intercept number at the end, which we use B to stand for, and that's our one-time number, or starting number. That's where, because it only crosses the y-axis once, the graph does. The only difference is now, instead of having an equal to sign, we're going to have these inequality signs. So let's go ahead and read our example. Jake is taking 4 of his friends to dinner. At the restaurant, a meal, side item, dessert, and drink costs $6.41. The first drink is included with the meal, but each refill costs 56 cents. Assume these prices include tax. If Jake does not want to spend more than $39 on the meal, excluding tip, which of the following inequalities can be used to find R, the number of refills Jake and his friends have? All right, so first of all, let's figure out what is going to be our slope number. The number that's changing here is the cost per refills, because depending on how many refills they get, our cost of refills will change. So it's going to be that 56 cents. Now, our y-intercept is that one-time cost for the meal. However, we aren't talking about just Jake. We're talking about Jake and his 4 friends. So that's a total of 5 people. So we're going to have to find out what is the cost of all 5 of their meals, because we're writing this equation for the whole party. So $6.51 times 5 is $32.05. So that is going to be our B. So if we look at letter A, the slope is not the 56 cents. So it's not going to be A. Okay. Here the slope's right in letter B, but the y-intercept is wrong. So that's going to be B, or it can't be B. So in letter C, we have 56 as our slope, but we don't have the correct y-intercept, so it can't be C. And then, so that only leaves D, so that has the right slope and the right y-intercept. And he doesn't want to spend more than $39, so he wants to spend $39 or less, which means it would be the less than or equal to symbol. So it's definitely D. All right, this is another word problem. Let's go ahead and read this example. Mike's bike shop needs to purchase some supplies. He needs 8 tires, which cost $5 each, and several water bottle holders, which cost $6 each. He does not want to spend more than $438 for 8 tires and the bottle holders. Which of the following inequalities could be used to solve for W, the number of water bottles holders he can order? All right, so first of all, let's identify our slope number. So our slope number is the per number. And then our y-intercept is the one-time number. So let's look at everything we know. So we know he has 8 tires he wants for $5 each. And then he has some number of water bottle holders for $6 each. Well, the amount that he's going to spend on tires, that's going to happen one time. That's not going to change. So he's going to have 8 tires times the $5 each is $40 on tires. So that one-time $40 expense is going to be our y-intercept. Whereas we don't know how many water bottle holders he's going to buy. So we have the $40 in tires for the y-intercept and the $6 for some number of water bottles on $6. That number is going to change. So which one of these has a slope of 6 and a y-intercept of 40? So A doesn't have a slope of 6. B doesn't have a slope of 6. C doesn't have a slope of 6. Okay, D does, and it has the y-intercept of 40. And if he does not want to spend more than $438, that means he wants to spend $438 or less. So I even have the right inequality, so my answer is definitely D. Thanks for joining us today, and I hope you learned something new.